In this video, I explain comparison of fission and fusion process. Left side we mention the point of fission process and on the right side we mention the point of fusion process. First point is a heavy nucleus split into two or more lighter nuclei. Means in a fission process the nucleus is divided, means it is split in a two or more lighter nuclei. Means here nucleus is uranium 235 and on this uranium 235 we bombard the neutrons. Okay, so when we bombard the neutrons, means uranium 235 is divided in a two parts, means it is split into a two or more lighter nuclei. So here you see it is divided in a two parts. Okay, and this weight of the two part does not equal to the total weight of this uranium 235, means not equal to the weight of the nucleus, because when they are split at that time some heat energy is released. So here you see in between the symbols the heat energy is released or a heat energy is liberated. Okay, that's why its mass is lower than the mass of the nucleus. Okay, means in a fission process the nucleus is split into two or more lighter nuclei. In a fusion process two or more light nuclei fuse to form a heavier nucleus. Fuse means they are joined. Now here you see this image. Okay, so this fusion process is carried out on the different hydrogen isotopes. Okay, so here you see this, the deuteriums and tritiums are the hydrogen isotopes and they are fused. Fuse means they are joined. So here you see these are the here the two atoms and here the three atoms and they are joints, and when they are joints they release the heat energy. Okay, and when we need to do the fuse process, means nucleus is fused, means they are joined. For this joining process we are required a very higher temperatures. Okay, and after these reactions they are provide the heliums and the neutrons. Second point, fission reaction does not normally occur in a nature. Okay, so in this nature, in this world, that is a fission process is not naturally available, but fusion process are naturally available. Energy liberated by the sun and the star is due to nuclear fusion. Okay, so we know that the sun is emits the radiations. Okay, so sun temperatures are the very high. Okay, so this temperature is high due to of the fusion reactions. Third point, about 1000 of the mass is converted into energy, and in a fusion it is possible to have 4000 of mass is converted into energy. Means during the fusion reaction more energy is produced compared to the fission process. Fourth point, fission produces many radioactive particles, and due to many radioactive particles the health hazard is high in a case of accident. In a fusion process few radioactive particles are produced in a fusion reactions, and due to that lesser radioactive material, that means the health hazard is much less. The process is possible at the room temperature, means fission process is done at the room temperatures, but the fusion process they are not possible at the room temperatures. For that we are require very high temperatures, because here the joining is carried out of the light nucleus. So joining process is required a very high temperatures, and here the splitting process are there, so they are occur at the room temperatures. This process give rise to chain reactions, means the chain reaction is increased continuously, and in a fusion process does not give rise in a chain reaction, means they are not continuously rise. For a fission the link of the process are the Newton, means this process is carried out due to the Newtons, and the fusion process are carried out due to the protons, or they are link of the process are protons. Now before moving ahead, I request to like the video and subscribe my channels for watching the more video related to power plant engineering and other subject of this mechanical engineering. In a fission process, it is possible to construct self-sustained fission reactors and have positive energy release. Means they are self-sustained, means we can control the fission reaction, okay, and they are produce the positive energy release are there. In a fusion process, it is extremely difficult to construct or control the fusion reactors. Okay, so fission reaction is controllables, fusion reactions are not controllables. Nuclear weapon which can be obtained using nuclear fission is atom bomb. Means some persons are create the nuclear weapon by using the nuclear fission process, it is called as the atom bomb, and by using the fusion process someone create the nuclear weapon, it is called as the hydrogen bomb. For fission process, the primary fuel is the uraniums and it is costly. For the fusion process, the main fuel is the hydrogen isotopes and are used as a fuel in a fusion reaction and are comparatively cheaper. In a fission process, temperature are manageable, means because it is carried out at the room temperatures. In a fusion process, temperature are very high, that is 100 million degrees centigrade. Okay, so these temperatures are unmanageable. So thank you for watching this video. If you learned something, then like the video, subscribe my channels and don't forget to share with your friends.